All right, let's dive straight into this explainer. Today, we're moving way beyond basic prompt engineering. We're going to look at the actual nuts and bolts of building complex, truly autonomous AI agents using LangGraph, and more importantly, how you can finally get some real, fine-grained control over your AI.
So, let's kick things off with a slightly provocative question. Why does theoretical learning so often fail to stick when we're trying to master these complex technical concepts? You absolutely know the feeling, right? You watch this brilliant demonstration, it makes perfect sense in your head, but then, 5 minutes later, you're staring at a blank screen and poof, the knowledge is just gone. Literally vanished.
Well, as our source material so brilliantly puts it, building real projects is a lot like driving a car. I mean, you can read all the manuals in the world about how a steering wheel or a gearbox functions, but your subconscious mind desperately needs that hands-on practice to develop vital muscle memory. And guys, that is exactly how we need to approach building AI agents. We have to build. Okay, so here's our roadmap for today. We'll quickly cover the power of practice, the blueprint of smart agents, mapping the user journey, dynamic breakpoints, rewinding with time travel, and finally, forking the agent's path. Let's jump into Section 1, the power of practice, moving from theory to hands-on execution. To really wrap our heads around LangGraph, we absolutely have to outline a concrete project. Because you can't just build a generic bot and expect to learn. You've got to target a highly specific niche. Maybe it's a student assistant, a health advisor, or a customer service rep. From there, the blueprint for your prototype requires a few key things: solid prompt engineering, tool integration, like giving it web search capabilities, and short-term memory through checkpoints, just so the AI actually remembers the conversation we're having.
Moving on to Section 2, Blueprint of Smart Agents, Designing the AI's Brain.
Now, when you're designing this brain for a real business use case, you have to treat your AI agent exactly like a brand new employee stepping into the office on their very first day. Think about it. Even if they're incredibly smart and capable, they don't know a thing about your specific business yet. You have to guide them step by step, feeding them that product-specific knowledge so they can eventually perform like a seasoned expert. All right, Section 3, Mapping the User Journey, Structuring the Conversation Flow. So to train that new digital employee, we need to map out precisely how they should interact with a user from start to finish. Let's take a conversational flow for a fictional company, say ABC Solutions. The logic naturally progresses from a simple greeting to understanding the user's specific issue, then authenticating their ID, maybe using a phone number, and finally routing them to the exact right department, whether that happens to be internet repair, an electrician, or a security service. Now, this flow really highlights a massive difference in how our agent's brain works: the difference between static and dynamic prompts. See, static prompts are your exact hard-coded greetings. Hello, how can I help? Simple. But dynamic prompts, they are a total game changer. They give the LLM flexible rules to handle unpredictable things, like complex, angry customer complaints right on the fly. You aren't writing the exact response anymore. You're essentially telling the AI, hey, if the customer is furious about their internet, respond with empathy and instantly redirect them to the internet service node. This brings us to Section 4, Dynamic Breakpoints Explained, where we look at controlling the flow. Okay, so to actually control that wild dynamic routing we just talked about, we use what are called dynamic breakpoints. Unlike static breakpoints, which, let's face it, just stubbornly stop the code every single time at a specific spot, dynamic breakpoints are much smarter. They only trigger an interruption when specific conditional criteria are met. It's essentially an internal pause that is based entirely on your own developer-defined logic. To make this super concrete, let's look at a specific code example straight from the source material. And they anchor this whole concept around one simple rule: the number 5. Basically, they set up a rule that checks the length of the user's input. So if a user types in hi, which is obviously just 2 characters, the graph executes smoothly and moves right along to the next note. No problem. But if the input is something like hello world, it throws a totally intentional error. Why? Because it exceeds our 5-character logic limit. The graph literally stops in its tracks and waits for us. Let's dive into Section 5, Rewinding with Time Travel, Inspecting the Graph. Okay, so what actually happens when our code hits that interruption? Well, LangGraph basically hands us a literal time machine. Using this amazing feature called get_state history, the graph creates a flawless timeline snapshot of the AI's exact state at every single node, from the start node to step 1 to step 2, all the way to the end.
It allows us to hit pause, rewind, and meticulously inspect the AI's exact thought process and data at any given point in its journey. How cool is that?
And this unlocks a massively powerful feature called replay. Replay means we can just grab a specific checkpoint ID and thread ID from our history and resume the graph exactly where it paused. Think about what that means. You don't have to start the whole conversation over from scratch, which, as we know, saves absolute mountains of compute time. It just seamlessly picks up right from that historical snapshot.
Finally, Section 6, Forking the Agent's Path, Editing the Past.
This whole concept builds into what I'd call the ultimate debugging tool. See, while replay simply restarts things from a pause, forking takes it to the next level. It allows you to travel back to a pause state, manually edit the underlying data yourself, and create an entirely new reality for the AI to continue from. You are essentially branching the timeline of your application. No way around it, it's basically sci-fi for developers.
So let's go back and fix our previous error, where the input was too long. We just fork the state, we jump in, manually replace hello world with a much shorter hi, we update the state with this newly edited information, and then we just watch the rest of the nodes execute perfectly because suddenly our 5-character rule is fully satisfied.
Ultimately, this gives us an unbelievable, unprecedented level of control. With the power of dynamic breakpoints, state memory, and literal time travel now firmly embedded in your muscle memory, it really begs the question, what incredibly complex autonomous systems are you going to go build today? Keep experimenting, keep practicing, and thanks so much for joining me in this explainer.